Hi, my name is Marco Cantù. Welcome to this CodeRage Mobile session about the development of database applications with FireDAC and IBLite running on the device. The specific focus will be on the development of a very simple master detail application showcasing all of these technologies. My name is Marco Cantù. As I mentioned, I'm the Delphi product manager. In the past, I've been the author of several books on Delphi and an independent trainer and consultant. Here is my contact information. My blog and Twitter account remain the same, but that's the new email address at Embarcadero Technologies. So the focus of this session is building iOS applications that target a database that's actually running on the mobile device. So the steps we have to go through is to look at the available databases on a mobile device, looking at data access technologies from Delphi and specifically focusing on FireDAC, look at live bindings, and finally we'll get to the source code of a complete demo. The starting point is the databases you can access directly on a device from a Delphi application. There are basically two options. One is SQLite. This is a database engine that is part of the iOS SDK, has the advantage of being already deployed to the device, so you don't have to deploy it, making the application smaller. Has the second advantage of being free, but it has some drawbacks, like it's quite light in terms of features, has no real security, works for simple data storage, and has limited metadata access, and is not extremely performant. Although for a mobile application, in most cases, that's actually good enough. The second option is to pick Interbase. Interbase has long had a version based on a DLL or dynamic link library called InterBase2Go that's been available for the desktop platforms. Now this is available in a different form because it's not a library, but it's code you embed into your own application. And it comes in two different versions in terms of licensing, and they are called InterBase2Go and IBLite. The first is a full commercial license. The second is a free license. Interbase is fully secured and has secure encryption, something that IBLite hasn't got. Both have full support for SQL, rich metadata, very powerful database features, fast data access, and really have the entire power of Interbase available within a mobile device. In terms of differences between the two, again, it's mostly driven through a licensing. You deploy the same server, the same application, but then you can attach an Interbase Lite or an InterBase2Go license. So that's the only difference. Your code is developed exactly the same way. There is nothing you have to do to switch from one version to the other but deploy a proper license file. And by the way, you also have, as part of RunStudio, a developer license of the full-blown Interbase server. Now, how can you access either SQLite or InterBase2Go, IBLite on a device? Well, Delphi comes with several different data access libraries. There is dbExpress, which is available for mobile. There is also IBX, which is available, although it was a separate download from the original shipping version of Delphi XE4. But the new feature that ships for the first time with the product, it was available before as an additional feature towards the end of the Delphi XE3 release cycle, is FireDAC. FireDAC is a universal data access library that at the same time has a lot of database specific features. So it lets you work at a higher level or drill down into specific requirements of a given database engine. FireDAC is available on Windows, on macOS X, and is also now available on iOS. FireDAC by itself has support for a multitude of databases, and even more through the ODBC driver. But again, it comes out of the box with support for Oracle, DB2, Microsoft SQL Server, and others that are not natively supported on the device because there isn't a version of these databases that can actually run on the iOS platform. So in terms of iOS support, it boils down to Interbase and to SQLite. Besides the specific data access code, FireDAC has non-visual component, in-memory datasets, and many other capabilities that are also fully available on iOS. So it's not only the physical drivers, but it's the entire FireDAC structure that has been ported over to the iOS platform. This means that you can use FireDAC instead of DB Express as a data access layer. And later on, I'll show you in the demo how this makes the code structure actually easier and more straightforward. In fact, FireDAC has core components that resemble more the traditional BDE components than the DB Express counterpart. There is a connection that is similar to an SQL connection and similar to the database idea in terms of BDE. But when we, for example, look to the AD query component or the AD table component, not only these components embed SQL commands or references to tables, but they also provide caching, storage, cached updates, and several other features that are not directly available on the DB Express datasets. These datasets are not unidirectional. They have full caching behind the scenes. So building an application is only the matter of hooking one of these data access components to the UI. And there is no need to add a client dataset or a provider, although you can use explicitly an AD table component to manage an in-memory dataset with lots of the features that are also present and available in the client dataset component. I mean, the client dataset component is available on mobile along with providers and other datasets, but using FireDAC, you have a simplified and easier and more straightforward architecture. How to get FireDAC is actually a separate download. It is available for iOS for all users that are entitled for the iOS support. So if you have Delphi Professional with the mobile add-on or RadStudio Professional, which includes mobile support, FireDAC is available also at the professional level. If not, FireDAC, the full-blown version and the version that includes support for Windows and Mac, is available either as part of the enterprise or higher SKUs of XE4 or as an add-on purchase for the RadStudio or Delphi Professional. Again, the version that includes support for Windows and Mac. The iOS version comes automatically with Delphi Professional with the mobile add-on. And again, it's a separate download from the registered users' downloads. The other technology that I'm going to demonstrate in this demo is visual live bindings. As you know, in FireMonkey, there is no concept of data-aware or data-bound controls, but to build a rapid prototype or even a full-blown application, you can use live bindings that have specific support for two list components, the classic list box and the high-performance ListView component that's been added specifically for iOS support. So live bindings allow you for rapid prototyping, but then you can customize the live binding expressions and fine-tune the application behavior in terms of mapping the user interface to the data behind the scenes. Now that I've focused on the various technologies that are behind the development of a master detail application using FireDAC and accessing to IBLite data, let us actually move to the actual demo. The first thing I want to do is actually show you how the resulting application works. This is not the simulator. This is actually my physical device hooked through Reflector. If I start the FireDAC iOS application, you can see a bunch of companies. So these are my customers, and for each of the customers, if I select, I get a number of invoices and the amount for each of these invoices. You can see there is a smooth effect moving from one tab to the other. This is a two-tabbed page, and it really has the proper or the expected behavior for iOS. So if this is the output of the application, let's look at how this is built by getting to Delphi running in a virtual machine on this Mac. This is all there is to the application. As I mentioned, if we start by the UI is made of a tab control, which covers the entire surface. It is aligned to the client area. And the tab control has two tab items. This is the one, the first one is visible. It has a list view and a toolbar. And the list view in turn has items with given parameters. And the second page also has a list view with a toolbar. We can switch to the second page by changing the visible tab, the active tab in the tab control. It's not much difference, but now there's a back button to move back to the first page. And the button is part of this toolbar. It's a back button selected in terms of style, and you see the actual structure of the button itself with the arrow pointing back. Okay, so let's get back actually to the tab control and start back with the first page. Okay, it is selected. So let's look at the data access. First, we have a connection. The connection is something you can customize in this connection editor. That's part of FireDAC. At design time, I'm hooking to a specific database locally, and I have the username and password, so I can actually test the connection at design time. And the other thing I can do, I can also open this connection. Before I go to that, I wanted to show that FireDAC has a number of options. You can see here from data mapping to BCD handling to string handling to parameters handling, fetching operations, row set, unidirectional or other mechanisms, specific support for master detail or live data for tables, and more. So there is actually a lot of information here and a lot of options here. And also you can get some information about the current driver, the current DB. For example, this is the physical client library that's being used at this moment at design time to connect to Interbase. There is also another page here that has the script that you can actually use to try out a query like select star from customers, you can actually figure out how this query works, and it's wrong because it's customer, and I can run it and I see the IDs and the names of the companies. So again, much more than what you get in terms of DB Express. It's a full console with lots of parameters, lots of settings to customize your database connection. Now, of course, this is a local URL, a local folder, not what you're going to use on a mobile application. What happens on mobile is that when the application starts, what we're going to do is actually to connect to the physical database file on the device. Actually, the database file is deployed as part of the application, and then the physical file name is replaced at runtime when the application starts. So what we have to do actually is to make sure that we remember to disconnect the connection and then open it after changing the value of the database property. The deployment of this GDB file, along with the deployment of the interface support as well, is part of the deployment configuration. So here you can see actually that the physical employee GDB file is going to be deployed on the device. And also what we are deploying, is the registration file for IBLite and potentially some other files. You don't have to know exactly how to set those features. What you have to do is actually to add some of these features files, and here select InterBase2Go for the simulator and the device, and the proper entries will be added automatically into this list. What you have to manually add is the physical database file and potentially replace the registration file with your own. Speaking of the specific database file, notice that this employee GDB file is the exact same file you can run on your local development machine or an Interbase server machine on Windows and potentially also on Linux. And the same physical file you just can copy on the iOS device and open it. There isn't a different file format or a different setting or a different version of the library. It's the same file deployed over. The only limitation on IBLite is on the size of the database. You can have a GDB which is bigger than 100 megabytes. If you exceed that limit, you have to get an InterBase2Go license for the mobile platform. So deployment is actually very important, but that's what I've already configured, and the configuration is the same whether you're using FireDAC or you're using DB Express for deploying your Interbase application. There is also another file that is embedded here. I think it's actually part of the project. There is a helper file that view source that is hooked here. It's called system startup copy. This will copy some of the Interbase file in the right folder on the mobile platform. So it is deployed to a folder, but some of these files are copied in a different location to be actually used at runtime. So it's just a helper file that helps you with the deployment of an Interbase application on the mobile device. So let's get back to our application and to the UI. Now we have the connection. The next step, of course, is to have a query. The query is very simple. Select start from customer. Again, we can execute the query. We can actually get the full preview of the table. You can also have a full preview of the metadata and the metadata mapping. Again, you can change the options and change some of the data mapping for this specific table. And potentially also messages back from the database level. So we can double check, we can make sure that our query is correct, is what we're looking for. And then what we have to do is to connect to this customer query data source. a data source component. That's actually going to be used for the master detail structure. And the next thing we have to do is we have configure the bindings to make sure that there is a binding from the link grid control, actually the ListView control, to this customer bind source. The customer bind source is another component that connects the two components, but honestly, this can look extremely complicated, but it is quite straightforward if you look it in the live binding designer. All I have here is the customer query, which is part of a bind scope and is hooked directly to the list view. And the visible item text of the list view comes from the customer entry. And the same customer entry is actually used to populate a label in the second page, in the second part of the designer. So while it might look a bit complicated in terms of graphical mapping, it is quite straightforward. The list view is hooked to the query in its entirety, so that's why we use star, and the visible text is just the customer. We can pick further elements for as header text, item text, or further graphical element for decorating the list view items. Now, the interesting side of this, using this design time mechanism, is that if we actually open and activate the query, we get something that's quite common from the Delphi developer's perspective, but quite unusual from the perspective of a mobile developer. We have actually the live data at design time. We can actually see how these items and elements will look like at design time. For example, we can also play with this configuration. Hey, what if rather than showing this item, we end up actually connecting a different field? What if we connect the city to the item text? Doesn't make a lot of sense, but you can immediately see what's the effect of a change like this. So let's get back to connect the customer name. So it's rapid, visual-oriented development using the graphical view, but also the live binding designer. Okay, now we have the core structure, and I'm going to disable the lifetime view only because the UI gets extremely cluttered at design time. So we have the connection, the query, and it's hooked. Now we have a second query, which is tied to a parametric query. We want to get a number of fields from the sales information for that specific customer number. So this is a parametric query. FireDAC lets you customize the parameter right within the query editor. You can also provide a default value and further information. You can again run the query and see the actual details, again filtered by that individual customer number. And you can change it and experiment with your query. The query, the value of the parameter, the customer number, comes from a value of the master table. But so what this sales query requires is simply a hook to a master source and a declaration of the master field, the name of the field that has to be used to fetch the value of the master element. In this case, customer number is the same name for the field as it is the name for the parameter, but it could be any name. I mean, there's not specific name matching. Again, master data source and master field to be hooked to the parameter value. Okay. Now with this information, we can look at the second part of the structure, which is again the description. We might want to look for the order dates, or we might want to look for the item tag, for the total value as in the demo I showed. And again, also in this case, what we can do is open the master table, open the detail table, get back to our tab control, select the second page at design time, and we can get to see the proper value. In this case, I've changed something compared to what I had originally, which was only the value, and I've added also a header with the date. If I remove this link, I get back exactly the output that I was seeing earlier. Okay, so again, you can customize your connections, customize the ListView and the ListView parameters, and immediately see at design time the kind of output you're going to get on your physical device, which again, it's not that common for a master detail database application written for the mobile platform. So what else is part of this application? We've seen there is a connection. There is an action list. The action list has two tab actions, change tab 1 and 2. These are hooked to the selections of the controls and to the back button. The back button is connected to change tab action 2. And this action in turn, as we saw earlier, changes to the tab item 1, so resets tab item 1. The other action, change tab action item 1, is tied to the selection of the elements in the first page, in the first list view. So the selection of an element of a list view executes the first action. And this is all of the code. I mean, this is the only, well, actually 3 lines of code. There is a reset of the bind source. There is the initial configuration to the database, and there is this execute action. But actually, it's almost no line of code, very little line of code for a rather complex master detail application showing data on a database on board your iOS device. There are 2 more components. There is a WaitCursor that you have to drop into the application, and you can tie it to FireMonkey. And also you need to deploy this further component that represents the physical drivers and drags in the proper units that are required by FireDAC to link into the driver. Differently from DB Express, where drivers are DLLs, you might have to deploy or compile into your executable. On FireDAC, all the drivers are based on Pascal source code, on Delphi source code, but you need to trigger which units you want to include and compile into your application. This is because the connection could be dynamically changed from one database to another. So you need to indicate which drivers you want to get into your app. If not, as soon as you start the connection, you'll get an error that the driver link is missing. Here you can potentially customize the vendor library and some other properties. But again, this is mostly a placeholder to get into the application the proper unit for FireDAC, which is in this case physical interface driver. So that's the structure of the application. It uses actions, it uses live binding, as I've showcased down here, can show live data at design time, and then you can deploy this application with the proper drivers and files, and you get a running application, as I was showing earlier, a full-blown master detail application running on mobile. Again, we can switch to it. This is the running application on the device. Item and details. And again, we can go back to the first. We remember there were 5 details, and this is the original app with those details. Easy to customize, easy to manage, easy to deploy to your iPhone, your iPad, or your other device. So let me finish by getting back to the slides. These are the features that we've seen in this demo. We can certainly open it up for questions.
Marco, maybe you've been looking at the Q&A log, I'm not sure, but there's several different questions related to how do you connect to a database from an iOS device where there isn't a client driver and or a iOS version of that database, whether it's SQL Server, Advantage Database Server, Oracle Server, whatever.
Yeah, the problem in that scenario is that the most natural solution is actually to go for a multi-tier approach. So you just use DataSnap or some other web service architecture and hook to the remote database. The problem is twofold. On one side, there are no or very few client libraries you can actually use on iOS, and it's not just that they are on release, but given that on iOS you cannot use dynamic link libraries, the only option is actually to compile the client library into your program, which is what we can do with Interbase because we own the client library, but it's not easy to achieve legally and in a way that doesn't affect the licensing rules for other databases. So partially is a technical issue hooking to remote servers, and again, Interbase should work remotely as well, but we don't really recommend it. The other issue is that on mobile devices, you generally have web connectivity, which is available, and maybe it's always available, but it's kind of has hiccups, goes on and off. So you might like move from one Wi-Fi to another one, or if you are on a cell phone infrastructure from one cell to another. And the thing is that if you are using something that is stateful, that is flexible, that is HTTP driven, then you can really move from one connectivity to another smoothly and keep hitting the same server. But in case of like a database connection, there is a significant issue when you are losing the connection to the DB that will probably create problems both on the server and on the client side of things. And moreover, given that devices don't generally live in the internal network, but they live on an external network, it's true that you can put them on VPN, but database administrators don't tend to be very happy to have like mobile devices on the field hooking to databases directly. So that's why a multi-tier model, either through DataSnap or through any other approach, is generally a better way for mobile development.
Yeah, and then there was a question about, can FireDAC, I'm not sure about the answer to this one, can FireDAC be extended with extra functions on iOS?
Well, you can. FireDAC has this notion of interpreting functions like with kind of macro, if that's what the question refers to. And this is a cross-platform. But in terms of adding server-side functions, like function that you hook, for example, to IBLite, that's actually an issue because Interbase provides the notion of extended functions through libraries, but libraries are actually not available on iOS. So again, we get back to the same problem that not having libraries on iOS causes some troubles, like it's impossible to have UDF extended Interbase functions.
Yeah, there's a question about I think it's here. It's from Rick as well. Working with IBLite with DB Express, working with tables, 8,000 records. Says it takes time on iPhone. He doesn't say what he's doing, whether he's doing a SQL select or pulling all 8,000 rows into memory from the database. FireDAC had better performance.
Well, FireDAC has better performance in the in-memory management. So the objects you have in memory, the in-memory table object is a little faster. The other thing that FireDAC has that might be good in this scenario is what, when using a table, there's this concept of live data window. So you can navigate through a table without fetching the entire table. It does a lot of things behind the scenes to just query the pages of the database data in a very flexible way. So it looks like traditional BDE navigating through table, with a relational DB behind the scenes. If that's applicable, then the speed difference will be very significant. If the FireDAC application has to do the same thing of the DB Express, running a query, fetching every record, it might be slightly faster, but it's not like radically faster. I mean, the extra speed improvements in FireDAC come from some of the features like array operations or this live data window or again, specific optimization that are built into the library. If you're doing exactly what you're doing on DB Express, there isn't a huge, I mean, there's still some improvements. The in-memory table is faster than client data set, but not by a large amount.
And then there was a question from Patrick. I think you see it there. He wanted to know if there's can you create an iPhone app where everybody can share data in one database? And again, if it's a IBLite bundled into your app bundle, then it's local to your sandbox, but you can always have shared databases elsewhere, right?
Yeah, you can have shared databases elsewhere. I'd probably tend to recommend using a NoSQL database like the Azure or Tables or the Amazon Web Services tables. Also, these have direct support from the Delphi IDE, and that they also work on iOS. That could be a very good option. It's very lightweight, easy to work. Because it's true that there are other databases that are hosted on the cloud, like Oracle or Microsoft SQL Server, but there's no direct connection from iOS to those databases. So it would be kind of tricky to use that directly. An option would be to have your own remote interface hosted somewhere on a virtual machine on the cloud and then hook to that interface. But I'm not really convinced this would be the ideal model. I mean, it's a possibility, but as far as I know, actually answering to another question, I don't know of any hosting company that has interface hosted. It would be nice, but I don't see it's terribly likely. But again, I really think that using NoSQL database, and I have a demo that I showed in one of the webinars I did a couple of months ago of pizza menus and pizza ordering demo, all done with Azure Tables and running from iOS mobile clients. So that's kind of model actually is very scalable, very flexible.
Yeah, Thomas is asking about the security, the interface security and interface to go, and the encryption is at the database level, at the table level, and even at the column level. So if you have IBToGo, not IBLite. IBLite does not have encryption, right, Marco?
Yeah, that's true. The encryption is at the physical level, so the entire database or individual columns, like credit card columns or whatever, but also the connection. So when you're using, for example, if you want to use interface remotely on a server and using your device, if you have the secure connection, though everything is encrypted in that traffic. Otherwise, things will move around like in plain text or something readable by a middleman attack.
And then interface to go, Alpha's asking about licensing. IBLite, you get an unlimited deployment license for that one transaction, 100 megabyte database size. But interface to go, it's you buy licenses for X number of users, right? And then you deploy your keys.
Yeah, the developer has a key and has to deploy that key. There is a callback mechanism, so we somehow kind of track how many different devices have that database working onto. And so that's the kind of the starting point for charging the developer. So that's the idea.
Yeah, the IBLite IBToGo static library that's bundled into an iOS app has a CallHome, which calls home to make sure that the license is valid and that you're not over deploying the number of licenses that you've purchased. And that's been the same way with Interbase Server, and it only checks on the app for startup.
Yeah, and if there is no connectivity, it doesn't stop working, so it's preventing it work. And it's also used if there is like anomalous usage, we can like stop the key, so you don't get charged if someone like steals that key or something like that. So there are some checks in place.
Question about, and this is more ListView. I don't know if maybe we save it for Serena or not. As far as if you don't want to have an accessor on a ListView, is there a choice? Are there more detail and?
Yeah, there is. The ListView has a subproperty that has some customization. I think the accessory you can remove and enable. You can have ask for a header or not. It's not differently from a list box where you can actually design the content of each and the style of each individual item. The ListView is less flexible, but being less flexible, it's very fast because each and every item of the ListView has the same height. So if you have 1,000, it's easy to compute the height. It's 1,000 times that value. While on a list box on FireMonkey, if you have 1,000 items, you have to ask each item, hey, how big you are. And the item, to know how big it is, has to check its internal component. So it really is a significantly slower component. I mean, a list box will be good for like a handful of items. But if you want to have hundreds and hundreds of items in a list box on iOS, it really will get too slow. But ListView is meant to be scalable, but on the other hand, is less flexible in terms of the UI.
There was a question here for C++ builder, but it's also Delphi. I guess it's more of a comment in that FireDAC has an ODBC bridge if you want for some reason to use ODBC to connect to your database backend, right?
Yeah, that's true. I mean, and on Windows and on Mac, FireDAC comes with a very, very long list of options. There is support for Advantage, so that was mentioned. There is support through ODBC for a bunch of other databases, some of which are kind of formally certified or tested. On mobile, the situation is different. It's not that FireDAC is limited, but the connectivity options you have on the mobile platform. And that's specifically true for iOS. I mean, Android is a different beast altogether. But on iOS, there are some real limitations on the databases you can access through an application.
Testing of software. Well, we have unit tests. We have unit test projects built in. You say file new unit test, so you can do unit testing. Ernest, he was talking about. Oh, sorry, Charles. He was asking about dependency injection. I know Nick Hodges did a talk at one of the CodeRages, whether it was 5 or 6, on dependency injection.
There are third-party libraries, and specifically there is a Delphi Swing library that has dependency injection support. So there are plugin libraries you can use in Delphi that offer this kind of features. It's not something that you get in the box.
Yeah, there's a ask for recommendation. Should they use AD memtable or client dataset for loading and saving files?
Yeah, this is kind of tricky because AD memtable is actually significantly more powerful. It just lacks 1 or 2 features of client dataset, but it's more flexible, uses less memory, it's faster, has several advantages, and also has the ability to do full SQL querying. So what you can have is you can have multiple AD memtables and even have a select statement that joins the tables. And so it's kind of a full database. However, in terms of loading and saving to different files and file formats like XML, JSON, or others, AD memtable is kind of weak. We certainly have plans in the future to add more mapping of ADMM table to different file formats than there are today. Today is not very flexible in that respect.
That FireDAC is really our multi-platform, our multi-device direction going forward, right?
Yeah. I mean, we have DB Express. We have DB Express on iOS. We'll even have it on Android. It's not disappearing any day. But the way going forward throughout the platforms is FireDAC. FireDAC is where we will add new database access features and new database drivers for going forward. And I see this question about support for DBF and FoxPro. That's actually possible, possibly even either through ODBC.
ODBC, yeah.
Or even through Advantage, although you have to install Advantage for that, which is free. I mean, the local version is free, so that could be another option. But actually, ODBC, through ODBC, you can even get some decent behaviors, not feature complete, but you can have even some decent behavior using FireDAC and the ODBC driver against paradox tables. I've seen some tests. You can not only read those tables, but even write and update paradox tables through FireDAC ODBC driver.
Have we? This probably comes up. Did we ever do any speed comparisons, DB Express through FireDAC? I know when we were evaluating acquiring the technology of AnyDAC DA-Soft that we did some comparison tests, but
yeah, we don't have anything published. If you just compare them, as I was mentioning earlier, and you build the same exact code on the two platforms, there is some speed difference, but nothing extraordinary. Where the difference comes in is that FireDAC has features, like, for example, if you have to insert 1,000 new records, you do with an array manipulation, you have a single statement, you pass the array of values you have to put into. I mean, then the speed becomes mind-blogging. The same when you're fetching tables. If you fine-tune the number of rows fetched by each fetch request, or returned by each fetch request, you can gain a lot of speed. If you're doing like an update on Oracle, you can go by row ID, which is very fast. So in most cases, the speed is not, I mean, just by translating the application, but by taking advantage of all of the extra features in terms of hooks to specific databases and, again, optimizations that FireDAC enables.
Marco, thanks for 2 great sessions today, and then you have 2 tomorrow, earlier morning, that want to hear more from Marco. He's on tomorrow at 7 a.m. and 7:30 a.m. 7 a.m. tomorrow, showing you how to use RSS feeds and XML parsing, and at 7:30 about how to take some of your VCL applications and start migrating them to Windows, Mac, and iOS using the latest version of the Meta converter, right?
Yes. See you tomorrow about those, and in the meantime, just send me email if you have any further questions.
Yeah, marco.cantu, C-A-N-T-U, at Embarcadero.com, and his blog is, what is it, blog.marcocantu.com?
Blog.marcocantu.com. Yep.
.com. Yep. Okay, great. Thanks, Marco.
Okay, bye-bye.